Hey guys, my name is Trevor Sullivan and welcome back to my video channel. In this video, we're going to continue learning about LXD. If you're brand new to LXD, LXD is essentially a utility that you can install on a Linux server, and it allows you to deploy both LXC containers and you can also create virtual machines running Linux or even the Windows operating system. So we're actually going to be taking a look at how to install a Windows 11 desktop system onto a headless Linux server that is running on a bare metal system up in my office area. And we are going to go ahead and install Windows 11 as a LXD virtual machine on that system. Now we're going to be building on some concepts that I've previously talked about. So if you head over to my channel at youtube.com/Trevor Sullivan and look for the playlist here called LXD Virtualization on Ubuntu Linux, this is going to take you through a lot of the concepts like networking and configuring remotes and things of that nature that are really important foundational concepts for you to understand as we dive into installing Windows 11 on a system. So what we're going to do is be kind of following along with the video here called Install Custom Linux Desktop Distributions Remotely on LXD, but instead of Linux, we're actually going to be installing Windows 11 instead. So feel free to watch that video if you want just a really basic introduction into how to install the Linux operating system as a desktop distribution on a LXD virtual machine. Also, if you subscribe to my channel, you'll periodically be seeing posts in my feed that have quiz questions right here, so you can kind of test your knowledge and figure out what kind of learning areas you need to be focusing on right here. So feel free to check out that community tab where we've got those quiz questions about various open source technologies. So let's go ahead and start through this process of getting Windows 11 installed. So the very first thing that we're going to want to do is to grab the ISO file, which is basically the DVD image for Windows 11. Back in the early days of IT, you'd basically just burn this image to a DVD disk, a writable DVD, and you would just insert that DVD and you'd boot off of it. So right down here, we can select Windows 11 Multi-Edition, click on Download, then we're prompted for a language. So of course, I'm just going to choose English right here. And then if I click on Confirm here, it'll initiate the download of the Windows 11 ISO file. But I don't use DVD drives anymore. I don't know about you guys, but I don't use DVDs anymore. And so we're not going to be burning this to a DVD. We're actually going to be booting directly to that ISO image. However, we actually have to do a little bit of tweaking before we can directly boot to it. So once we have the Windows ISO downloaded, we need to copy just that raw ISO file over to our remote host. So to do that, I'm going to fire up a utility here called WinSCP. You can download WinSCP on the Windows platform, and essentially what it is it's a graphical client here that allows me to create an SCP session to my Linux server over SSH, and then I can simply drag and drop files onto my Linux server so that we can copy them from my local system up there. So I've already got a directory here with my ISO file downloaded, so I'm just going to go ahead and drag and drop that onto my Linux server here under my home directory, and then we're going to use that ISO file. We actually have to run a conversion on it first before we can directly boot to it, but we're going to use that in order to create our Windows image. So that'll take just a moment here to copy over, but while that's copying, let's go ahead and talk through the setup steps that we need to do in order to use that ISO image. Now, there's a great post here from somebody named Simos, who had posted a couple of years ago about how to take a Windows ISO and convert it. With Windows 11, we are required to have a TPM, a trusted platform module, for the encryption of things like BitLocker drives and whatnot. So we're actually going to attach a virtual TPM, which isn't covered in here as well. But this does tell us that we have to use this utility called distrobuilder, which is another open source utility from the team that's working on LXD. And distrobuilder actually has this command called repack Windows that allows us to take our standard ISO file that we download from Microsoft as input, and then we can basically output a custom file here that is ultimately used by LXD to boot our virtual machine. So that's one piece of software that we're going to have to get installed is distrobuilder. And as I was working through this, I actually found out that there's a few prerequisite packages that we have to make sure that we install that are actually used by DistroBuilder. So I made sure to post those right down here on this discussion forum for Linux containers. So go to discuss.linuxcontainers.org and you'll be able to find this post archived there. So what we're going to do for starters is make sure that these prerequisite packages are installed on our bare metal Linux server that we're going to use to run virtual machines. So I'm already logged into my system here. If I run lsb release -- all, you can see I'm running Ubuntu 22.04 LTS. Again, this is a server system, so there's no desktop environment installed or anything like that. So I'm going to go ahead and just paste in this command to install gen ISO image and a couple of other packages. And then once these prerequisite packages are installed, then we can install distrobuilder and run the command to convert the standard ISO into the LXD compatible ISO image file. So we'll let those prerequisites install with apt-get, and then in order to install distrobuilder, we're going to use the snap package manager, which is pre-installed in Ubuntu Linux servers. So we'll go ahead and run snap install on distrobuilder. It does use classic confinement for snap, so you have to make sure that you do -- classic. And you don't have to do -- edge here. I generally prefer to use more stable versions of software packages, so I'm just going to stick with the standard version rather than grabbing the edge version, which could potentially have some instability in it. So we'll let these packages install here, and we'll just keep an eye on the process of copying this file over to our server. Looks like it's almost done here, so it should be ready to go once we get distrobuilder installed. So let me just pause this really quick while these dependencies install, and then we'll get distrobuilder installed. All right, so we've got our prereqs installed now, and we should be able to run the command gen ISO image right down here. Sure enough, that is installed just fine. And we should also be able to run the Wim tools down here. I can't remember exactly what that utility is called, but let's just do Wim tab. And as you can see, we've got commands like Wim append, Wim apply. And so all these Wim tools have been installed that allow us to modify Windows images. So now we'll just do a snap command, say snap, sudo snap install on distrobuilder -- classic. And that should get distrobuilder installed. And we should already have all the prereqs available for distrobuilder to work properly. So then we'll just run distrobuilder, make sure that it's not complaining about any dependencies, and then we'll run the conversion process for our ISO, which has just finished copying. So I don't need WinSCP on my system anymore. By the way, if you don't have WinSCP installed, you can grab WinSCP and many other utilities from the Scoop package manager over here, which I use to install all my dev tools on my Windows system. So now that we've got distrobuilder on our Linux server, let's just run distro and then builder, and that should run just fine. And then as you can see down here, we've got this repack Windows subcommand. And so this is going to include everything that we need to launch Windows on a LXD virtual machine. So let's do a distro builder repack -Windows. We'll specify the input ISO, which should just be the Win11 ISO right here. So we'll just do capital W, lowercase in, and just tab complete that. And then we'll specify an output file. So I'm just going to give this a different name, like -repacked.iso. And we'll also add on sudo in front of that so that we can run the conversion. Now, because the Windows ISO is pretty large and the injection process is basically unpacking everything from that ISO and then repacking it into a new ISO, this command can take some time to run. So I'm just going to pause the video once again while this is running. All right, so after just maybe 3 or 4 minutes right here, we should see that our output is finished right here. It's basically just going through and modifying the Wim file, which contains the Windows image, and then it repacks it as a new ISO image. So now if we do an ls-lga, we should see right down here at the bottom that we've got our repackaged ISO file here, and this is the one that we're actually going to be mounting to our virtual machine, so we don't actually need access to the original ISO file any longer. All right, so now that we've got our repacked ISO with distrobuilder, we need to go ahead and create a virtual machine. So of course you're going to want to make sure that you've got LXD installed, which you can always do with a sudo snap install LXD. And once you've got LXD installed, you can just run LXC version to make sure that you've got it installed. And you also need to run through the initialization wizard, or you can just do -- auto to use all of the default settings for LXD initialization. So once you've done that, we can go ahead and launch a new virtual machine, do some configuration on it, and then we're actually going to boot it up from our local Windows system rather than the remote Linux server, because we need access to the graphical console, very similar to if we plugged a monitor into an HDMI port or display port on the virtual machine. So what we're going to do for starters is say LXC init --VM, because by default, LXC creates a container, not a VM. --VM tells it to create a VM. We're going to call it win11-03. And then we also need to set a couple of config options. So we'll say config limits.cpu equals 3 to give it 3 CPU cores instead of a single one by default. Then we'll do limits.memory equals, how about 6 GB, just to give it a little extra capacity. You can change that to whatever value is appropriate for you, but generally I like to do a minimum of about 4 gigs for a Windows virtual machine. So we'll go ahead and run that, and then we also want to do -- empty here because we are creating an empty virtual machine. Now, one thing that we're going to want to do is to expand the default hard drive that gets associated with this virtual machine. So what we'll do is say LXC config device override, and then we're going to override the root file system for our Windows 11 VM. So we'll say win11-03 is the VM we want to modify. The device we're modifying is the root device, the root file system, and then we're going to plug in a size of about 40 GB, and that should be plenty to at least get Windows installed. All right, so now that we've got our device overridden here and we've got a larger hard drive, let's go ahead and actually add a trusted platform module. So something that's interesting about LXD is that it allows you to add a virtual TPM, very similar to a motherboard that has an embedded TPM on it. This basically just allows us to associate a virtualized TPM with our Linux virtual or our LXD virtual machine that's going to run Windows. And Windows 11 does require this. You can technically create a custom ISO that kind of disables the requirement of a TPM, but I wanted to keep things as kind of vanilla as possible so that you're doing minimal customizations and we can just stick with using the official ISO from Microsoft. So what we're going to do is just add this TPM. We'll say LXC config device, and then we can just say add a new device, and then we specify the instance, the win11-03, the device name, we'll just call it TPM01, and then the type, which is just TPM. So we'll say add win11-03, TPM01, and then device type of TPM. So now we've got a TPM virtually associated with our virtual machine, and now we also need to mount the ISO file to the virtual machine. So once again, we're going to say LXC config device, add, and we're going to add a disk resource to the machine here. So we'll say add to win11-03. This will be, we'll just call it DVD-ROM. You can call it whatever you want to. And then the type is going to be disk, and the source is going to be the fully qualified file system path to the ISO file. So go ahead and just do an ls here, grab this file name right here, and just tack it on the end right there, and that should be good. And it looks like we are missing source path right here, so let's see what's going on. And of course, I just totally realized what happened here. I actually specified home Ubuntu here, but I don't have an Ubuntu user. I have a Trevor user, so I need to go back here and fix the path to that to say home/Trevor/win11 ISO. All right, so now we've attached that ISO to our virtual machine, and now we can go ahead and attempt to boot it up. I did want to point out that in the directions right here, it says to set secure boot equal to false, but because we added a TPM to our virtual machine, we shouldn't need to specify the secure boot disabled option right here. So go ahead and just leave that enabled and don't run that command. So now we're ready to go ahead and launch our virtual machine, but we can't do that from this headless Linux server because it doesn't have a graphical environment. We're just SSH'd into it. So what I'm going to do is use a local shell on my Windows system to use the LXC command here to start up the virtual machine and then attach a graphical console to it. Now, if you need to install the LXC CLI, you can use the scoop package manager as well. So if I just do a scoop list LXC right here, you can see that I've installed the LXC client. You can't run the LXD engine or server component on Windows, but you can use the LXC CLI tool to remotely connect to an LXD server. So we are going to do that. And then the other utility that we need is called Virt Viewer. So if I do a scoop list on virt star, you can see that I've installed this Virt Viewer utility. And Virt Viewer is this open source software package here that allows you to get an interactive graphical terminal to a remote virtual machine that's running over on my bare metal Linux server. So if you watched my video that covers LXC remotes or LXD remotes, you'll know that we can use the LXC CLI here in order to connect remotely to our server right here. So the first thing I need to do is on the server, make sure that we have a listener configured with core.https address. I'm going to have it listen on the default LXD port, which is 8443. And then over here, I'm going to say LXC remote add. I'm going to call it Pangea. And the IP address here, let's just do a grep on 10. And it looks like it's 135 here. So we're going to go ahead and just add that IP address. And then once we configure this remote and confirm its fingerprint, it's going to prompt us for an admin password right here. So we're going to say LXC config trust add, plug in the client name, which is Artemis. That's my client system here. And then we're going to copy this token and paste that token in. So now we have this trust between LXC on my Windows machine and the LXD engine on my Linux server. So now I can do LXC remote switch Pangea, and now any commands that I run on the LXC CLI locally here are actually running against my Linux server. So now I can do LXC list win star, or actually just win here, and let me see if it'll come up. Sure enough, there it is, win 1103. So we haven't started it yet because we started it with an empty disk and then we attached the ISO. So what we're going to do is say LXC start win 11-03 -- console equals VGA. Now, as soon as we run this command, because we specified a VGA console, the Virt Viewer is going to get fired up automatically. And make sure that you hit escape right away when this virtual machine boots up so that we can go ahead and specify the boot device that we want to use. Otherwise, it's going to try to do a Pixie network boot right here. And it looks like I missed that, so I'm going to go ahead and close that, hit the up arrow to rerun that again. And it's popping up on my other screen here. So let me just do an LXC stop on that VM -- force, and then we'll go ahead and launch it once again. That should fire up a new window for me. And I'll just hit escape really quickly. And now you can see that I've actually got the BIOS config. So I'll go down to boot manager, and then I'll specify that I want to launch from this virtual CD-ROM device. And then I can go ahead and just hit a key to invoke the boot from the Windows ISO that we repacked with distrobuilder. So this is going to bring up a standard installation here, and because we attached a virtual TPM, we should meet all the requirements for the Windows 11 setup right here. So we're just going to run through the installation, say I don't have a product key for now, go down here to say Windows 11 Professional, and then we're just going to do our basic prompts here, plug in our disk configuration right here to install to our 40 gigabyte disk. And this is going to run through the installation process. Now, after the installation process completes here, you're going to see that it just goes to a blank blue screen, and you might be tempted to forcibly restart the system, but it actually is going to disconnect our graphical terminal every single time that the VM reboots. So you're not going to want to force reboot the system. You'll actually just want to reattach the graphical console to the system. One other thing that can happen as well is that you can run out of disk on your Linux server as well. This can especially happen if you're using the default ZFS storage pool. So what we're actually going to do over here is go ahead and create a directory-based storage pool on the disk itself because I do have plenty of space available. I'm only using 6% of my SSD right here. So what we'll do is just mount a directory for LXD. So what I'm going to do is just go into the slash data directory here, and I'm going to use this data directory as the root of my new storage pool. So what we'll do is say LXC storage list. As you can see, I only have ZFS storage pools here. So what we'll do is say LXC storage create. We're going to create a new pool called dir01 using the dir driver, and we're going to set the directory to slash data. So I'll say LXC storage create, and then we're going to call it dir01 using the dir driver, and the source is going to be slash data. And we're actually going to put the virtual machine into that storage pool instead. So what we'll do is just go ahead and delete the virtual machine right here, and then we're going to recreate it. So we'll rerun our init command, but this time we're going to specify -- storage equals dir01. That'll create it in the new location. In order to configure the size of our virtual disk, we're going to use the LXC config device set command this time. For some reason, since we're using the directory storage driver, it wants us to use set instead of override. Then we'll make sure that we have our TPM chip here as well. I actually already ran that command. We want to make sure that we mount our ISO as well. So we'll do a search for our ISO command right here. And I actually ran that command already as well. And now we can go ahead and try to reinstall the Windows operating system. So we'll just go ahead and relaunch our virtual machine. So let's go ahead and stop it, make sure that it's stopped, and then we'll try to restart it once again. So we'll use the start command with the VGA, and we'll rerun through the installer. All right, so now our virtual machine is going to restart right here. And so at this point, after the VM restarts, we're just going to get this blue screen. So we'll X out of this, and the VM is going to automatically come back up. So this is where we're going to use the console command in order to reattach to the graphics interface of the virtual machine. For some reason, the VM decided not to come back up on its own, so I ended up having to just use the start command and reattach to the interface here, but this time we're not booting to the ISO file, we're just booting directly into the disk so that Windows can finish its setup process, and then we can go ahead and proceed from there. All right, our VM is restarting once again right here, so let's just see if it decided to stop itself or restart this time. And it looks like it is actually running, so let's just use the console command this time to reattach to it and see what's going on with Windows Setup. And it looks like Windows Setup is still running here, and in just a moment we should be presented with the final setup wizard so that we can set up a login to our virtual machine. And here it is, it looks like it's coming up right here. So one of the first things that I like to do is if I just want to set up a local user account, we can hit Shift F10 in the installer right here. And inside of this CMD window, we'll just do OOBE/bypass NRO. And that will cause our system to ignore the network requirement to do Windows setup. It'll reboot the system, and then we can actually disconnect our network and proceed with setting up a local account instead of having to use a Microsoft account to set up. So let's close it out once again, and we'll reattach once again to our console right here, and hopefully this time we can set up a local account. To do that, you could either just remove the network interface from the virtual machine on the LXD server, or you can take the shortcut, which is to just do an ipconfig release. So we'll say ipconfig/release. That will release the DHCP address. And now, when we get to a certain point in the setup wizard, it will allow us to use a local account. So let's skip a second keyboard layout. And it's going to complain that we don't have a connection. So we'll click I don't have internet, and we'll say continue with limited setup. They really try to kind of encourage you to use a Microsoft account, but now I can go ahead and just set up a local account. So let's just confirm our password right here. We'll just plug in a couple of security questions, and provide answers to them as well. And then we should be taken into our full Windows environment. All right, so we've confirmed all of that. We'll just confirm these default options right here, choose accept, and hopefully it'll take us to either our login screen or our desktop right here. This setup screen right here should take just a moment, so just let your virtual machine continue running. Awesome. So now we have our Windows 11 desktop right here. It might take a few moments for the system to become responsive just because as a virtual machine, it's a little bit on the slow side and it needs to finish some setup here. But one of the first things that I want to do is actually enable remote desktop so that I can remotely access my Windows virtual machine. So to do that, I'm just going to go ahead and plug in the remote option here, go down to remote desktop settings, and we just want to switch that on. And the other thing that you might want to do is to rename your system. So what we can do is just open up our terminal here, search for terminal app, and then once we fire up PowerShell here, let me make sure that I run that as administrator. So I'll right click it and do run as admin, confirm our UAC prompt, and then there's a PowerShell command that we can use just called rename computer, and then say dash new name is going to be win11-03. And that will require us to restart. So we'll just say restart dash computer. And after our machine comes back up, we should be able to remote into it using that name, assuming that it's connected to your network. Now, one of the things that I didn't do is set up a Mac VLAN connection. So we're actually going to have an internal IP address on the bridge network. But if you watch my video about networking, you'll see how to set up a LXD profile that uses Mac VLAN. And I already have that set up, so I'm just going to go ahead and add that profile to my VM. We'll say LXD profile add, and then we'll do win11-03 Mac VLAN, and that will attach it directly to my physical network. But remember, if your bare metal system has a Wi-Fi adapter instead of a wired adapter, then Mac VLAN simply isn't going to work. All right, so we are going to need to reattach to VirtViewer once again right here if we want to be able to see the console because our system restarted once again. However, hopefully this time we can go ahead and just RDP into it. So let's just do MSTSC. We'll plug in our VM name, which is win11-03. Go down to our authentication details and plug in our auth, password, and username. And then we should be able to get an interactive desktop on our Windows 11 virtual machine that's running on LXD on our bare metal host. All right, so as you can see, we've got our RDP session up and running here. So now I've got a fully functional Windows 11 virtual machine running on top of my Linux host. So feel free to follow along with these directions if you'd like to get a Windows 11 system. Don't forget that the ZFS pool that's configured by default on your Ubuntu Linux system can run out of disk space, and the process to expand the ZFS pool is a little bit onerous, so you'll probably want to set up a storage pool using a directory instead, just to keep the disk configuration relatively simple. So I hope you enjoyed this video and learned something new, and we'll see you in the next video. Take care.